Okay, so now that we had some practice with figuring out the value of velocity and acceleration from a position equation, we're now going to go over how we can figure out not just the velocity and acceleration values, but specifically where a particle or an object is speeding up and or slowing down from the position equation. So in this example, we have the position of a particle given by the equation f of t is equal to t cubed minus 6t squared plus 9t. And we're first going to figure out the acceleration. So the acceleration in general, and then figure out the acceleration after 4 seconds. So remembering that the position function, tells you where it is at any point in time, but the rate of change of the position function is the velocity function. So velocity v of t, v of t is equal to f prime of t. Because remember, velocity is the rate of change or the derivative of position. Likewise, acceleration tells you the rate of change of velocity. So a of t is v prime of t. So to find a of t, we first define f prime of t or v of t, then we differentiate v of t, and then we got a of t. So we got to basically find two derivatives. We got to differentiate this equation twice. So let's go ahead, let's figure that out. V of t will be the derivative of this, which will be 3t squared plus, well, not plus, minus 12t plus 9. Then a of t will be the derivative of this, which will be 6t minus 12. So that's our equation in general for a of t. So the acceleration at 4 seconds will be a of 4 which is simply 6 times 4, 24 minus 12, or 12 feet per second squared. Okay, now in part B, we got to figure out when the particle is speeding up and when it is slowing down. Now, this it really requires you to make sure that you don't simply make the mistake that velocity is the same as speed. Remember that velocity has a sign because velocity has a direction. Speed doesn't have direction. Speed is always positive. So, in other words, if we have like velocity is equal to negative 50 meters per second, that's the same as having a speed of 50 meters per second. It's just basically saying it's going in the opposite direction or the negative direction. Now, why is that important is because the key to answering this problem is analyzing the signs of velocity and acceleration and figuring out when they're both the same and when they're both opposites. Because when acceleration and velocity are the same, they're working together. So the object is going the object is speeding up in some direction. If they're both positive, it's speeding up in the positive direction. If they're both negative, it's speeding up in the negative direction. When they're opposites, the velocity is slowing down depending on the sign of each function. It may be slowing down in the positive direction, or it may be slowing down in the negative direction. To better understand this, let's actually analyze the sine function, and let's make it so that the sine function is going to represent velocity. Because again, this is really key for you to master so that down the road you don't get all stressed out about this. So the popular sine function, something like this, right? Goes up, goes down, and we're going to say that the sine of t is going to represent velocity just for this example. And what we want to do here is break this graph up into 4 intervals starting at 0, another one at the peak here, or when t is pi over 2, another one here when t is pi, and another one here when t is 3 pi over 2, and then the final one over here when t is pi, or 2 pi. Now, why break it up there? Well, because on those intervals, the velocity or acceleration functions change sign. So, for example, if let's make a table. Actually, I advise make a table for this stuff. That's what I'm going to be doing. Let's make a table breaking intervals up at these points. So going from 0 to 2 pi. So we're going to go from first 0 to pi over 2, then from pi over 2 to pi, then from pi to 3 pi over 2. That's not what pi comma 3 pi over 2. And then from 3 pi over 2 to 2 pi. And then we want to analyze the signs of the velocity and acceleration graphs in each of these intervals. And we're going to say what's going on with the motion of the object. Okay, so from 0 to pi, velocity is positive because it's above the t-axis. It doesn't matter that it's going up and then going down. Velocity is always positive from here to here. So we're going to put a positive symbol all along here. But then from here to here, velocity is negative. Okay? Now, what about acceleration? Well, let's remember, acceleration is the derivative of velocity. So acceleration is basically the sign of the tangent lines of this graph. So if we were to make some tangent lines from here to here, where if we were making a tangent line at any point here up to pi over 2, these tangent lines have positive slopes. So the acceleration is positive up to pi over 2. But at pi over 2, after sine reaches a local max, the slope of the tangents in this interval are all negative. So acceleration becomes negative from pi over 2 to pi. Let's keep on going. From pi to 3 pi over 2, acceleration is still negative. Acceleration is still negative because it's still, having a negative slope. So we're going to put another negative sign there. But after 3 pi over 2, acceleration becomes positive because the slope of the tangent line is positive. And then we can look at how these signs compare. So on 0 to pi over 2, we can say that the object is speeding up in the positive direction. So we can say speeding up, it's speeding up. I'm gonna put positive direction just to save some space. Speeding up in the positive direction. Because again, velocity tells you the direction it's moving, and it's moving in the positive direction or to the right if we're saying the right is the positive direction. Now here, velocity is positive, but acceleration is negative. So it's still moving in the positive direction, but the velocity is decreasing. It's slowing down. So it's slowing down here. It's slowing down in the negative direction. Or let's actually, to make this a little more clear, it's speeding up, positive direction, but it's moving to the right. It's slowing down, but Actually, I said that wrong. It's slowing down, but it's still moving. It's still moving to the right. It's still moving in a positive direction because acceleration is positive. So it's slowing down. The direction is still it's still moving to the right. So let's actually call this direction. Let's make a little row right here to show direction. So this is the direction the object is moving. It's moving to the right on this entire thing, but it's speeding up here and it's slowing down here. Now, on this next interval from pi over 2 to 3 pi over 2, or sorry, from pi to 3 pi over 2, both velocity and acceleration are negative. So they're working together. So it's actually speeding up still. It's speeding up, but it's speeding up in the left direction. Because again, velocity is saying it's moving to the left, and acceleration is working together with it. So it's speeding up and moving left. And then finally, in this last part, it's still moving left, but acceleration and velocity are opposites. So they're working against each other. So it's still moving to the left, but it's slowing down. So this is the key idea when you want to figure out where an object is speeding up or where it's slowing down. Find where the acceleration and velocity functions change signs and then compare them across intervals. So the key to finding out where to find those intervals is figuring out where is the acceleration 0, because over here we'll have horizontal tangent lines, and where is the velocity 0. So let's go back to the original problem. So to figure out where the particle is speeding up and when it's slowing down, let's start off by figuring out the zeros of velocity and acceleration. Zeros of v of t and a of t. So let's find where velocity is 0 and where acceleration is 0. So we're going to have, where is v of t equal to 0? Let's first go with that one. So if we set this equal to 0, we can factor this to take out a 3, and we get a t squared minus a 4t plus 3. And furthermore, we can make this 3 times t minus 3 times t minus 1. So the zeros here are going to be at t equals 3 and t equals 1. Okay, that's for velocity. Now let's look at acceleration. We're going to set acceleration equal to 0. So we got 0 is equal to 6t minus 12. So t will, and you can see here, the t will then be 2. So we're going to then now divide our intervals at these 3 points, starting at 0. So let's make a little table. Well, it doesn't have to be little, but I mean, make a handy table that you can organize and make your lives a lot easier. So t, we're going to go from 0 to 1 first. Then we go from 1 to 2. Then we go from 2 to 3. And we go from 3 to infinity. And then let's look at what's going on with velocity. And let's look at what's going on with acceleration. All right, so now let's understand that to figure out the sign is not don't worry too much again about solving it, or don't worry about the tedious part of this, because again, you just need the sign. You don't need the exact value. A lot of the time it may be easy, but sometimes maybe you're gonna get functions that'll be maybe complex, and don't spend a lot of time like precise calculations. Once you know what the sign is, you're good. So in other words, let's pick any t value in here. Let's just pick let's have a test value. Let's test 1/2. T equals 1/2. Here we'll test 1.5. Here we'll test 2.5. And here let's just test 5. So we're going to plug 1/2 into the velocity and acceleration graphs. So if we take v of 1/2 and a of 1/2, and on the worm, I'll save you the algebra work, and I hope you just trust me. If you plug in 1/2 into here, you'll get 3.75 as your velocity. If you plug in 1/2 into a of t, over here, you get 1/2, you get 3 minus 12, so you get -9. So you get a positive value for velocity and a negative value for acceleration. Now here's the thing. You can always plug in every value into each one of them in case you're paranoid or worried that you made a mistake or something. But it's not actually necessary because if you remember, if we look at acceleration, so this is a tip, see the acceleration only had a 0, 2. So we know it's not going to change sign possibly until 2. So we know it's going to be still negative until here, because that's where we found the 0 of acceleration. But again, it doesn't hurt if you are worried about or get stressed out doing a problem. You can always plug it both in. Now, same idea for velocity. If it's divided at 1 and at 3, so I can just have the same velocity sign here because my velocity gets divided at here and here. But again, it doesn't hurt. So let's plug in 1 of 1.5 into the velocity equation. So v of 1.5, you calculated. So we'll plug it into here or here. And you're going to get negative 2.25. So you're going to get a negative value for the velocity. If you take a of, again, if you decide to take a of 1.5 into the acceleration equation, you're going to get -3. So yes, you get a negative value. Now let's see v of 2.5, a of 2.5, and v of 5 and a of 5. So this is really just a tedious part, but again, it's make sure you understand it. Don't rush this part because you don't want to have a mistake or confuse yourself. Like everything has to work, make sense. So we have to find v of 2.5, a of 2.5, and then v of 5 and a of 5. Okay, so using super quick calculations, I found that we get -2.25 here for v of 2.5. A of 2.5, we get 3. V of 5, we get 24. And a of 5, we get 18. And feel free to verify my work, get that practice in. So then at 2.5, we're going to have up here a negative symbol, negative value for velocity, and here 3 or a positive value for acceleration. And then finally, we have positive and a positive for both. Okay, so now let's analyze this chart. What's going on here? Well, let's just first say where it's speeding up. It's speeding up on this interval, 1, 2, and this interval, 3, infinity. But remember, the direction is different. So on this interval, it's in a negative direction, speeding up and moving left, we'll say, on 1, 2. That's what that is. It's speeding up and moving right on 3, infinity. Moving right on 3, infinity. And then that means it's slowing down on the other intervals. So it's slowing down on 0, 1, but since velocity is positive, that means it's slowing down and moving right on 0, 1. Slowing down and moving right on 0, 1. And it's slowing down and moving left on 2, 3. Slowing down and moving left on 2, 3. All right, so there you go. Yeah, I know these ones aren't, quick, but they're fun. And if you get this down, you're gonna have a much easier time. The physics problems are gonna be easy. So good luck, and I hope this helps. Happy practice.